3D visualization you just saw is the topic of this project, and I'm going to show you how it is done. So let's begin in geometry nodes, because I want to switch the key for something else. You can use whatever geometry you want, but I will be using icosphere. And because we will be extruding and subdividing a lot, we need to start with a simple low poly geometry, because we want the faces to be separated from each other. To achieve this, add a split edges node, and after that we will add a scale elements to scale down the faces. When you are done with the scaling, the next thing we will be adding is a subdivide mesh node with a subdivision level of 3. And of course, you can adjust the level of the subdivision as you want. You can do more subdivisions, but remember, the price for this is the longer render time. Now, after the subdivision, when we have more faces, we'll be extruding them. So add an extrude mesh node. But we don't want the faces to be extruding the same way, so check individual. This option will also keep the individual faces separated from each other and be independent from the surrounding geometry, which is exactly what we want. Now we need to start a new node chain in order to make the structure, and we will start it with a simple subdivide mesh node. In this case, we want the edges to fill the empty space between the faces. So one simple way how to extract them is converting mesh to the curves. But what we are missing right now is the thickness and some dimension of the curve, because we want to make it 3D. To do so, we will convert the curve back to the mesh. So for the thickness part, we need to add a curve circle node. Put the radius down and the resolution to something like 8. So now add a curve to mesh node. And what you're about to do right now is plug the curve circle into the profile curve. If it is too thin, you can just increase the radius. Alright, so now we have two parts. We have the edges and the faces. For now we can leave them separated, because what we are about to do right now is the actual animation. So add a Voronoi texture, set it to 4D, F1 and Manhattan type. And finally plug the position to the offset. As you can see now, this will create a good looking pattern from the gaps between the faces, which creates the first half of the visual interest of the final animation. And since we are using the 4D type of the texture, you can just play with the W value to make infinite variations. Now we will be using the distance output to drive the offset scale. Plug the distance output into the math node and set it to multiply. Add another one and plug the value output to the offset scale. After doing so, your faces should be extruded randomly, which is part of what we want, but we are still not there. Next, add a value node and plug it to the first multiply input. Insert a keyframe inside the value node and go to graph editor. If you don't see the line inside the graph editor, you need to select the value node. Now it's time to bake my track to curve. So go to key, click on bake sound to F curve feature and select the audio file of your choice. That will be controlling the extrusion. When your file has been converted to curve, if you play the animation you will see that it's actually working, but we cannot hear the music yet. Now there are two options to fix this problem. You can either add a speaker or you can just load the music file into the video editor. So go to the video editing and just drop the file. Make sure that it starts on the frame 1, otherwise it won't be synchronized with the visualization. Then play the animation and try if it's synchronized. Alright, so now it looks like it is synchronized, so let's move to the next step. If you play with the value of the second multiply node, you can adjust the strength of the extrusion. Now, this step is optional, but I want to have order in the nodes, so I'll be controlling the strength with another value node. There are many ways how you can adjust your animation, so if you want to have different settings, go ahead, play with the options. You don't have to copy exactly everything that I do here, but if you want to go with different settings, I recommend at least staying with me until the end of this tutorial, to avoid the chance of you getting lost during the workflow. Okay, so now we have the extruding faces and also the structure, and we will join them together. So add a join geometry node and connect both ends to the join geometry input. As you can see, the extruded faces can be also visible from the inside, so we need to fix that. To fix this, we just need to connect the subdivide mesh to the join geometry node as well to hide the inside. It can be also used as a solidify modifier alternative, and the structure can be more visible, so I'm gonna increase the thickness. Now we are almost finished, but last step is the ring. Add a curved circle, then convert to mesh, and as a profile we'll duplicate the curved circle and plug it to the profile curve. The thickness is too big, so we need to put down the radius. Of course, if you want to be more creative you can add more rings, but I think for the demonstration one is more than enough. Also, join the ring with the rest of the geometry. If you are about to do a close-up renders or close-up animations, I recommend to increase the resolution of the curved circle, so we have smoother surface. I want the ring to react to the music as well, so I'm gonna add scale elements. You can also use a transform node or whatever you prefer. Now, because I want the scaling to be only on the X and Y axis, I'm gonna use combine XYZ node. We will add two math nodes. First one will be set to multiply, the second one will be set to add. Let's use our already keyframed value, which is the source of the whole motion for the animation. Bring the whole collection closer and just plug the value output to the mathematic input. Afterwards, take the value output from the add node and plug it to the multiply first input. Plug the keyframed value to the combine XYZ node Y input, and the value output of the multiply node to the X input. Now we can control the size of the ring. So right now we have a procedural audio visualization that we can control and manipulate however we want. But the visualization itself, it's still kind of boring, so I'm gonna make a particles inside geometry nodes. Go to the geometry nodes, add a cube, scale it up to fill the entire visualization space. If you watched some of my previous videos, you might already know the way how to make particles fast and easy in geometry nodes. First, convert your mesh into the volume, then distribute points inside the volume. Afterwards, add instance on points node. The object that will be instancing is our particle, and because I like spheres as a particles, I'm gonna use UV sphere. And before plugging it into the instance input, make sure it's shaded smooth with set shade smooth node. Then just scale the particles on the size you want. And also increase the density. If you want more variations between the scale of the particles, you can add a random value and plug it to the scale input. This will make some of the particles smaller and some of the particles bigger. Our particles are ready right now, but we need to set a material for them. Now let's create a quick particle material. So create a new material and name it as a particles. Go to geometry node and link the material with set material node. Then go back to the shading tab. Delete the principal BSDF shader and add emission shader. And because I don't want all the particles to have the same color, I will use a random value from the object info node. Then you just add the color ramp, set the colors that you want and just play with the sliders. You can also increase the emission strength if you want. Now let's deal with the icosphere. Add a set material node and place it to the node group between the join geometry nodes. So the material will be set on the icosphere only. So let's start with the shading. So delete the principal BSDF because we will be using an emission shader. Let's start with the layer weight node. Now we have this black and white gradient which we want to convert to colors. So add a color ramp node and just add colors you want. Now if you are struggling with colors and you don't know which color combinations are looking good together, here is a great example of color schemes you can use, or you can just generate it with Colors website. Link is in description. Now back to the tutorial. Add emission shader and mix it together with the glass BSDF. For the mix factor, we'll be using a phasing output of the layer weight. If you want to have a better control about the factor, just add another color ramp node and play with the black and white sliders. With this setup, you can basically control the amount of glossiness. Now the glass has no details and no imperfections, and I want to change that, so I'm gonna add a Voronoi texture, which will drive the normal value. Choose the settings that you want and add a bump node, and make sure that the distance is connected to the height. Also, I recommend decreasing the strength a little bit. Also, if you want the emission to be more visible from the inside and from the center of the visualization object, use the phasing output of the layer weight node and plug it into the emission strength. And of course, if you want to have a better control, add another color ramp node and just play with the black and whites. I also recommend using the easing type. It will allow you to have a smoother transition between colors or black and white values. You can review the material in the render mode to see how it will appear in the final render. That would be for the icosphere. Now we can finally animate our scene. So place a camera in front of the visualization object, add keyframes to the rotation and just play with the settings. If you want to have the same rotation around the visualization that you saw on the video from the beginning, you can do the similar effect by parenting the camera to the empty, which is located in the center of the scene, and just animate the empty rotation, which will work also for the camera. So that's it. This was the tutorial about how to make a 3D visualization in Blender. If you want to learn a similar stuff in the future, hit the subscribe and like button. I get views from you and you will be provided with the content that you want. Thanks for watching and see you in a future video.